Today we are going to be covering section 6.8, and this is the complex number system. I just wanted to remind you that the complex number system is the number outside of the real number system. So in the real number system, here we are, the real number system. In here we have all of the integers and the rational numbers and the irrational numbers, everything in the real number system. Outside of that real number system, there is another system called the complex number system. And it is inside of the complex number system that we have the capability of taking the square root of -1. And the way that that is possible, I can't get my negative to go there, the way that that is possible is by using the letter I. So we have now defined the square root of -1 as I. In the past sections, when we have tried to do domains and domain restrictions, we've said, hey, you can't take the square root of a negative, but that's because we've been graphing in the real number system. Well, now we're not graphing in the real number system, we're graphing in the complex number system, and so we are allowed to take the square root of -1. I'm going to take this opportunity to just remind you of a couple properties of I here. Now, as we just talked about, I is the square root of -1. We also can deal with I squared, and just like a square cancels out a square root, when we square the I, we get just -1. Well, if we continue on with that pattern, we can get I cubed, and I cubed then will equal -I. And the way that we got that is you take I times I squared, so you just get -I, or I cubed. Now, I to the 4th is like taking I squared and I squared, so for I to the 4th, that's going to be 1. Now, this pattern is really important. We're not going to go much more into it right now, but I did want to remind you of this pattern of 4 that we have when we're talking about i's. So the first thing that we actually want to do before we get into that pattern is we want to be able to simplify a square root. Now, we've been talking about simplifying square roots. The difference is we want to be able to simplify square roots that are negative. So we have the square root of -25. And the square root of -25, normally the square root of 25 would just be 5. And you guys are really good at knowing that. But because there's a negative inside, we want to add that I onto it. Not literally add it, but multiply it by the 5. Because we're taking the square root of a negative. So it's like we are including that square root of -1. So then we have 5i is the simplification for the square root of -25. We can do this with other numbers. Let's do another example here. So if we have 7 minus the 2 square root of 36, 2 square root of -36. That's what we want to do next. 7 minus the 2 square root of -36. Now, the square root of -36 is, just like we talked about before, 6 is the square root of 36, but because it was negative, we have to tack that I on there. So the square root of -36 is 6i. And then we're just going to follow the order of operations here, and 7 minus 2 times 6i is going to be 7 minus 12i. And you can easily see how we got that from here. All right, so we don't always have perfect squares inside of our square roots. But when we don't have perfect squares and we still have negatives, we're going to have 2 plus the square root of -18, for example. Okay, 2 plus the square root of -18. Now, this is a negative number right here. So in our answer, we know we're going to have an I, but what number do we put with the I? Well, we want to simplify this just like we have before. So we're going to list some factors of 18. And I chose 9 and 2. I could have chosen 6 and 3, but 9 and 2 is a little bit easier because we have our perfect square right there. So this perfect square, or the square root of 9 is 3. But remember how it was negative, so we've got to tack that I on there. And we still had the square root of 2 that was left over. So you have 2 plus 3i root 2. And that is the answer there to part C. Okay, so now let's look at one more Now in this class we have studied the quadratic formula, and if we haven't, we're going to. And when we do that, we are going to want to be able to simplify statements that look like this. So 2 minus the square root of negative 48 over negative 4. Okay, 2 minus the square root of negative 48 over negative 4. And when we simplify this, we're going to start by factoring the 48. And just think of anything that you can that goes into 48. The first thing I thought of was 4. 4 goes into 48 12 times. Now, there's another perfect square that goes into 12. We'll still have our 4 there, but the other perfect square that goes into 12 is another 4 and 3. So we actually end up with a pair of 4s that we're going to take out. But remember how we had a negative there? Well, because that's negative, when we take that pair of 4s out, we're actually going to make it 2 minus 4. But because that was negative, we have to put an I in there. And then if you look here, we have a 3 left over, so it's going to be 2 minus 4i square root of 3, and that is still all over the negative 4 that we have there in our denominator. Now, if you look really closely at this, all of these have a common factor. The 2, the negative 4, and the negative 4 there. They all have a common factor of 2, and so we have to take that out. So we're going to divide all of those. 2 divided by 2 is going to be a 1. The 4 divided by 2 is going to be a 2i square root 3 over negative 2. Okay? And I normally won't leave the negative in the denominator. I like to change it so that my negative is in the numerator. And then that would be your final answer. The 1 plus 2i square root 3, divided by 2 would be your final answer there. My eraser's not working. Hang on just a second. There we go. Okay. So now you can tell that that is separated. You're like, what is that T thing right there? Alright, well, there is a... none. There we go. There is a negative 1. Okay, so negative 1 plus 2i root 3 all over 2. That's our final answer there. Okay, so those are just some pretty basic ways to simplify the square roots. Let's talk about some operations with I for just a minute. So I am going to share my screen here, just 1 second. Okay, so what I want to do next here, this will be example 2, what I want to do next here is combine some like terms. And when we're adding complex numbers, you really are just straight up combining some like terms. So if I have 5 plus 2i times, plus, sorry about that, plus negative 3 minus 6i, and I want to combine these. I literally am going to treat the I like a variable and just combine the like terms. So 5 minus 3 is what we're going to do first. We're going to do the 5 minus 3 because those are the like terms, so that's this 5 and this negative 3. And then we're going to do the 2i and the 6i, so plus 2i minus 6i, and we're going to combine those because those are our other like terms. So 5 minus 3 is 2, and 2 minus 6 is negative 4i. And there you have the answer to this first problem. And that is how you add the complex numbers. Okay, for part B, we're going to do some subtraction. So we have negative 4 minus the square root of negative 27, and then that whole complex number. Now don't get confused here. A lot of students, when they see these parentheses, they overlook the minus between the parentheses and they think that now we've got some multiplication going on. We don't have any multiplication going on, okay? Don't make that mistake. See right here how we're subtracting in between, even though these are in parentheses. The only reason they're in parentheses is to show I have one complex number that I'm going to combine with another complex number. This minus right here is to just separate them and show you the operation between those two complex numbers. So don't look at the parentheses and say, oh, it's multiplication. Look at the sign between the parentheses to see what we should do. And if I might be so bold, the first thing that I am going to do is I am actually going to distribute this negative. So I had a negative there. I'm going to make it a positive and then change this to a negative here. Hang on just 1 second. Change that to a negative and then change this one to a positive. So what I did there is I went through and changed the sign because this was subtraction. I just distributed my negative to both of these terms, and that's how those signs changed all of a sudden. So then before we do anything else, I am also going to simplify my roots here. So we have the square root of negative 27. I'm going to change 27 to 9 and 3. So the square root of 9 is 3. We're subtracting here, but because it was negative inside, I'm going to make it a 3i, and then we have the square root of 3 plus a negative 2 plus, now we can't take the square root of this one, and so we're stuck with that negative inside. We're just going to have I square root 3. And so then when we combine our like terms, we've got negative 4 minus 2, which is a negative 6, and negative 3i root 3 plus 1i. Remember, there's a coefficient of 1 right here. So when we do the negative 3 plus 1, we have a negative 2i root 3. And that's the final answer. So the negative 6 minus 2i root 3 there, that is your final answer for this problem that we had up here.